Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called One with the Circus by Jeff Wages, or Wages. I'm not sure how you pronounce it. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row column and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have using red, green, and blue, color in all circles such that orthogonally adjacent circles are different colors, and the digit inside a circle appears that many times in circles of that color. So, for example, in adjacent circles cannot be the same color. So these cannot be red because they are adjacent, orthogonally adjacent circles, which means cells that share an edge with each other are different colors. So none of these circles here are red. None of these circles are green then because of the same reasoning. And we have to use red, green, and blue in the circles. And a digit inside a circle appears that many times in circles of that color. So we could have, well, that should tell us a lot actually about things. Anyways, what we could have is we could have a 1 in this red circle and a 1 in this green circle. And that would work because the 1 appears once in all the red circles, but it also appears once in all the green circles. So normally in circle puzzles, where circles usually appear the same amount of times in circle, the digit can only appear that amount of times in circles, period, normally. But in this, since we have special coloring with red, green, and blue, it's just how many circles can that digit appear in digits of that color, or circles of that color, I should say. I hope that was clear. But those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. There are circles in every box except one. So for 9 to be in a circle, it would have to have a circle in each box because 9 can only appear in each box once. But since there are no circles here, 9 can never appear in any circles because it would have to appear 9 times in that color circle, and it can't appear in every circle then. So this has to be in this box 9. 9 has to appear there. It must appear in row 7 here. It must appear in row 9 here. In row 5, it can't be here, and it can't be in a circle, so 9 has to be here. 9 has to be one of these 2. 9 has to be one of these 3. Well, we know 1 through 8 must appear in circles, then. At least however many times it is. So 8 must appear in a circle in all 8 boxes which have circles. So 8 has to appear here in that box because that's the only circle in that box. Can't appear in box 1. Must be in a circle in box 7, so it has to be here. Must be in a circle in box 2 and 3, so 8 is one of these 2, 8 is one of those 2. 8 can't be here, here, or here. Well, actually, no, it could be there. Can't be here or here in box 9. Can't be here. Can't be here. Can't be here. Okay, so where is 8 in box 5? Can't be here because of 8 has to be one of those digits, so this must be 8 here. Whereas 8 in box 8 can't be here or here because 8 in one of these two cells, in this cell and in one of these two cells, can't be here, so 8 has to be here. 8 cannot be here and here in box 9, so it can't be here, so 8 has to be one of these two cells, and then 8 has to be one of those two cells there. So 8, where is 8 in row 1? It cannot be in, it has to be in a non-circle, but it can't be here because this has to have an 8 in the circle there. And it can't be here because of 8's in the columns, so 8 must be here. We have 7 guaranteed. Okay, so how many circles? I should probably have started with this, and I usually do, but I was just like already figuring out where it could be, where things could be. Where is 9? Actually, where's 9 in column 6? It has to be here. So that's 9 because it can't be in a circle. Therefore, 9 in column 8 cannot be here. 9 has to be there. Where is 9 in box 3 then? Can't be here or here because 9's in the columns and rows. And it can't be in a circle, so 9 has to be there. We know where is 9 in box 5? It has to be there. Where is 9 in box 8? It must be here. So we have 8 9s now. We know where the last 9 has to be. It has to be there. Again, as I said, normally I count the number of circles to start with in these I don't even know what they're called. They're basically have circles match the number of times digits in circles must appear that many times in the circles. But yeah, not completely sure what they're called. Anyways, let's continue. Let's count how many circles we have. We have 2, 4, 7, plus another 7 is 14, plus 4 is 18, plus 8 is 26, plus 6 is 32, plus 4 is 36, which means every digit appears the same amount of times as the digit itself. Because we have to have 1 through 8 because of box 9 appear in circles. And 1 through 8 adds up to 36. Let's just double check. 1 plus 3 is 4, plus 3 is 7, plus 4 is 11, plus 8 is 19, plus 1, 2, 3, 4, 5, 6 is 25, plus 7 is 30. Wait, that's 38. Huh, I miscalculated. Oh, I think I said 2 here. Ah, that's the reason why. So good thing I checked. Okay. So that means we have 1 through 8 guaranteed, and either we have extra 2. So it has to be 2 appears. It could be 1 appears twice. So 1 appears in each of the colors, or 2 appears in 2 colors. And 3 and 4 must appear 3 and 4 times. So again, 1, 2, this is 4. I messed that up earlier, so that's 6. Plus 3 is 9. Plus 7 is 16. Plus 4 is 20. Plus 8 is 28. Plus 6 is 34. Plus another 4 is 38. So we have 2 extra digits that we haven't accounted for. Again, it cannot be an extra 3, because that would require 3 more digits, which would add up 36 plus 3 is 39, and we have 38 circles. So it's either 2 is in 2 colors or 1 is in all 3 colors. We're not sure which. Okay, so 8 has to be one of these 2 digits. So 8 cannot be red. because it's guaranteed to be next to a red in one of these cells. So 8 has to be blue or green. We're not sure which. 7 appears. 7 must appear in all the remaining boxes because this is the only circle in circles. Because this is the only circle in box 4, and we don't have a circle in box 1. So 7 has to appear one of these two. 7 also must appear here, and this must be 7. So this is a 7-8 pair. So 8 is a certain color. We'll mark that as... let's make it yellow. 7 has to be the other color, which is not red, because this is 7, 8 as a pair, so it cannot be red. It must be blue and green. We'll mark that as orange. So this is an orange-yellow pair, which cannot be red. 7 cannot appear here in box 5, so 7's one of these two digits. So 7 cannot appear here, 7 can't appear here. This must be a 7-8 pair here, because those are the only place it can be remaining in box 6. And this is a yellow-orange pair also. 7's one of these two. 7 cannot be here. 7's one of these three. 7, 8 cannot appear here, so this is also a 7-8 pair. And this must be orange and yellow. Because 7 cannot be here, it's one of these three. That means we are guaranteed a 7 in rows 7 and 8, in box 7, and in 7 and 8 in box 8. So therefore, the rest of rows 7 and 8 cannot contain a 7, and 7 can't be here because of a 7-8 pair in the column, so this must be a 7-8 pair, which means this is orange and yellow here, and therefore this is blue or green, and therefore this can't be blue or green, it's red. Hmm. Huh. Now we have to look at 6. That doesn't work. Oh, wait, hold up. We don't know 7 has to be here. Oof, that's rough. Okay, never mind. We have to clear that out again. Ugh, okay. This has to be 7, 8 as a pair. This does not. 7 could be in the red. So, okay, where is 7 then? 7 has to be one of these two, so this can't be 7. Where is 7 in row 1? Can't be here because it must be in a circle. Can't be here because it must be in a circle. Yeah, that was a pretty bad error. But I don't know. For some reason, I don't see the colored circles. Anyway, 7 can't be any of these. This can't be 7 because 7 must be in a circle here. So this must be 7 here. 7 and 8 cannot be here, so 7 has to be one of these two. Which means this can't be 7. So 7's one of these three. These can't be 7, so we still have that 7. And 7's one of those three. Okay. 6 has to appear. 6 cannot appear in a circle in box 2, 1, or 4. So okay, so we're making 8's yellow. We don't know which one it is, though. Wait, 8 doesn't have to be here either. Okay. 8 could be here also. Ooh, okay. Shoot. 9's are still right. 8's are not, though. Ugh. Well, okay, this can't be 8 because we're... Okay. Let me just redo this. Where are 9's? 9 has to be here, 9 has to be here, 9 has to be here, 9 has to be here. This can't be 9, so 9 has to be here. This can't be 9, so 9 has to be here. 9 can't be here, so 9's there. 9 can't be here, 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 so this is 9 there, which forces 9 to be there. 8 has to appear in circles in each box. So it has to be, that's the only one there, can't be here, so it must be 8 there. It has to be one of these two. So it can't be here, so it must be here. 8 can't be here, can't be here, can't be here, so 8's there. 8 cannot be here, or cannot be here. 8's one of these 3. 8's one of these 4. 8 cannot be here or here, so it has to be one of these 2. Okay, there we go. I messed up earlier. I don't know why, I just completely ignored the... I just can't see the red circles or the green circles. 7. 7 has to appear here. This must be 7, so this is a 7-8 pair here. 7 must appear one of these 4. 7 can't be here, so 7's one of these 2. 7 can't be here, it's one of these 3. 7 can't be here, it's one of these 3, which means these can't be 7, so 7 has to be one of those 3. 6s. 6 has to appear here, so this must be a 6-7 pair. 6 is one of these 4. Not 7. 6 is one of those 4. Oh, where is 8? 8 cannot be here in row 1, no, nor here, so this must be 8 here. 7. Cannot be in circles in columns 1 and 2. Okay. We are guaranteed a 7 in one of these cells and one of these cells. 7 cannot appear in any of these cells in boxes 2 and 3 because they must be in circles, and it must not be here because of the 6-7 pair in the column, so this is 7 here. Where is 6? In row 1, so the remaining digits in column 3 are 1 through 5. This can't be 1 because of 1 in the box. The rest of box 7 is 1 through 5, and this can't be 1 because of 1 in the column. So 6 can't be here. This is also 1 through 5, but no 1 here because of 1 in the row. So 6 has to be one of these 2. Right. It has to be here. It has to be one of these 6. Oh, wait, this could be 7 also. Oof. Okay, I keep missing the colored circles. I'm not sure why. This is definitely 7 here. Hmm. So we have 6 here. 5 has to appear in all the circles, so this must be 5, 6, 7, 8 in boxes, because we can't have a 5 here, we can't have a 5 here, nor in box 4, nor in box 7. So, right, this is 5, 6, 7, 8. That eliminates 5 in the rest of the box. So this is 1 through 4. These cannot be 5 through... Yeah. In the circles must appear 5... Okay, so this has 5 in 5 of the boxes. That means 4 must appear in circles in the rest of the remaining cells. So this cannot be 4. It cannot be 5. It can't be 6, 7, or 8. So this is 1, 2, 3, We have 1, 2, 3 here, or 1, 2, 3 there. I'm gonna pause. I need to go to the bathroom right now, so I'll be right back. Okay, and I'm back. Let's continue. Um, hmm. Um, hmm. So we again have either 1 is in all 3 colors, or 2 is in 2 of the colors. Um, 8 could be red. It's possible. Heck, this could even be red, too. We know blue and green are here. So this is blue and green. These are all red or blue. Oh, wait, yeah, so no, 8 cannot be red. Okay, there we go. So 8 cannot be red because 8 has to be here, 8 has to be here, which means 8 cannot be here or here in box 5, so it has to be there, which means 8 cannot be any of these, 8 has to be one of these two. And these both have to be blue or green because they cannot be red. So 8 cannot be red, which means 8 is one of these two here. But 7 could be red, right? 7 can't be here. It's one of these two, but that only eliminates 7 from being here. So 7 could be any of these 4 here. mm. So 8 is blue or green. We don't know which one, though. So 7 could be red. We have a 5, 6, 7 quadruplet in row 3, which eliminates 5, 6, 7 in the rest of the row. So this has to be 1 through 4 here. Interesting. This can't be 1 because of 1 in the row. We have a 2, 3, 4, 5 quadruplet in box 1, which eliminates 2, 3, 4, 5 in the rest of the box. This is guaranteed to be 5. One of these 3 is a 5 here, so this cannot be 5 here. That forces this to be 6 here, so this cannot be 6 here. And this is a 7, 8 pair. 5 eliminates 5 in the rest of the column here. This 6 means this can't be 6 here, so 6 has to be one of these two. So this is 2 through 6 here, 2 through 6 here. 7 cannot be here, so this is 1 through 5. One is guaranteed to be one of these two here. Okay. This is 5. This is 7, 8 as a pair. Obviously, one of these could be red. Hmm. Okay. This has to be 2 through 5 remaining. And obviously this could be 1 through 6 here. We are guaranteed a 1 has to be in one of these 8 cells here. We are also guaranteed 1 has to be one of these cells here, but it could be 1 being there, right? Ah! We are guaranteed a 1 in one of column 6, but we are also guaranteed a 1 in our circle in column, or sorry, box 9, which is a completely different set. So we must have 3 1s, 1 in each of the 3 colors. So 2 can only appear once, or twice, essentially, in circles, and it's the same color. So we're guaranteed a 2 here in column 6 and in box 9, which means we cannot have a 2 in a circle anywhere else. So in box 6, that's not allowed because it's not going to be in columns. So we have a 2 guaranteed either in box 5 or in box 8. We don't know which. It has guaranteed also to be in box 9. So therefore, we cannot have a 2 in box 6. So therefore, this must be 2 here, which means this can't be 2 here, no 2 here. We are guaranteed, well, we could have a 2 here or 2 here. This cannot be 2. So we are guaranteed 3 1s in circles. We have 2 2s, 3 3s, 4 of 4. Okay. Right. And 1 and 3 are guaranteed. One of them, one of each of them is going to be in either box 5 or box 6. Sorry, box 5 or box 8. And one of them is guaranteed to be in box 6 for both, and same as box 9. So missing has to be 1, 2, and 3. Okay. That doesn't help us too much. Hmm. So none of these can be 1 or 1, 2, or 3 here. This can't be 1, 2, or 3 either. Because if we have a 1, 2, 3 here, it has to appear also in 1, 2, well, if we have 1, 2, 3 here, we're guaranteed a 1, 2, 3 here, a 1, 2, 3 here, and a 1, 2, 3 here, and that's too many 1, 2s, and 3s in circles. So this has to be 4 through 7 here. This is 4 through 7 also as a possibility. 2, well, 2 could appear here. So 2 in row 5 is either here or here. We're guaranteed 1 in row 7 in one of those. Hmm. So 3 is the same color, 2 is the same color, 2 through 9, 2 through 8, sorry, is all the same. They have to be the same color. 1 appears in each of the colors once. So that's 3 ones. And then we have a 3, obviously. These digits, remaining digits in column 6 are 1 through 6, obviously. This can't be 2 because of 2 in the column. Sorry, 2 in the row. Ew. Hmm. Okay. So how do we start differentiating these then? I mean, all 5, 6, and 7. 6 and 7 are in different colors. Because they're next to each other. So since 6 and 7 are in different colors, it cannot be 3 reds. Right? Because if they are in... If it's 3 reds, then 8 would have to be non-red, and then, yeah, 6 and 7, so... 1 out of 6 or 7 is in a non-red. Which means 5 has to be in a red. So 5 cannot be here. 5 has to be in a red. And then the other one is 6 or 7. We're not sure which. So the other 6 or 7 has to be next to the 8. And so it has to be essentially a... So one of these two is red. The other... So, yeah... So 8 is yellow. Let's just start that with yellow. 1 out of 6 or 7 is red. The other one is the non-red. So we'll mark it as orange. And it's also non-yellow, right? Because it can't... 6 and 7 has to be next to the 8 if it's not red, right? So this cannot be red. So this must be essentially a orange-yellow combination. And it requires the 6 or the 7. Okay, so how do we disambiguate that? We know 5 is definitely in a red circle. So 5 has to be one of these 4 here. One out of 6 or 7 is also in red. These cannot be yellow. So this must be a red-orange combination there. These can't be yellow. but they don't have to be different colors. This is red and orange again. Don't really know what this. This cannot be. These cannot be yellow. These can't be yellow. Interesting. That means there could be a yellow here. There could be a yellow here. We know one has to be in the yellow set, but we don't know if any of the other colors have to be. Hmm. This cannot be yellow, so this is red or orange because it's next to the 8. We don't have any other restrictions on yellow, really. Um, so this has to be one color, and these are two other colors. Right? Let's make this, I don't know, medium and dark then. So this has to be medium. These can't be yellow, so they must be dark. Which makes this medium color and this dark. Because again, these cannot be yellow because they're sharing an edge with yellow cells. Same with this, but this one we don't know. This we're just setting it a different color. We don't know which one it is. One of them's red, though. This could be yellow here. That's fine. Hmm. Hmm. We do know that this coloring is correct. um. Hmm. 2 cannot be here in box 9. So 2 is one of these 4. That doesn't tell us much. Okay. Hmm. 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 So 2 could be here, which would force then 2 to be one of those two. That's fine. So you could have 5 and 7 as a combination there. 5 cannot be either of these digits. We don't know if 7's red. Frig. Okay, so it could be 5 there. Never mind. Hmm. 5. You could have 4 here. So you could have 4, 5, and 7. We just know 5 has to be red. We don't know where it is, though. We know 8's not red. Because it must be in one of the blue-green cells here. Okay. 7 and 8 are different sets. 8 and 6 are different sets. So is 8 and 5, obviously, because 5 is red. 8 must match sets only with 1, guaranteed. We don't know about 2, 3, and 4. Hmm. What other sets do we have? We have the geometry here. Huh. Okay, we know 2. Actually, 2 could be here. I don't know why. And once I color it, I guess the circles just disappear from my vision. Hmm. Hmm. Okay. Yeah, I have to figure out how the circles geometrically fit each other. Um, Let me pause again. I need to go bathroom again. I've been drinking a lot of water because I've been coughing a decent amount, so I'll be right back. Okay, and I'm back. Apologies. I actually didn't realize I didn't pause. I did come up with one new thing, and that is that this cannot be red here. Because if this were red, that means all of these digits would not be red. And we know 2 out of the digits from 5, 6, and 7 are guaranteed to be red. So they have to, in every place where they appear, in every place that they appear, 5, 6, and 7 appear in a circles in a box. There have to be at least 2 reds. So if this were a red, that would guarantee there's only 1 red in this box, and that's not allowed. But we only have that one, really. that we got that information from. Um, hmm. One has to. Okay, so in the spaces where um, red has to appear twice in each of the boxes, which again have 5, 6, and 7 in them. And it has to have 3 reds in one of those boxes because one has to appear in the red color once. Um. Hmm. Hmm. So this could be 1, 2, 1, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6. No 6 here. Okay. Hmm. These have to be 3 different numbers because 1 and 3 must appear in a circle here. 1 and 3 must appear in a circle here, and they can only appear in a circle in one of these 6 cells. So then it must appear once in one of these cells. Same with 2. 2 cannot appear here. It does definitely appear here, and it appears in one of these cells, so 2 has to be one of these. So these are uniquely different digits, guaranteed. Huh. So this is A, B, and C, guaranteed. C has to be one of these 3. A and B are both here. Huh. Okay. I'm trying to think what happens if, like, you have blue here. Well, okay. Hmm. Because the thing is, 8 is not guaranteed to be blue or green, right? It could be either one. We're not sure which one, per se. Hmm. Um, hmm. Blur, blur, blur. Okay, let's say 7 was in the red. That would force this to be 6 and this to be 8, which would force this to be 7 and 8. This would be red. This would not be yellow, it would be orange, which means this is not orange. This is obviously yellow in that case. I mean, it seems like it's okay-ish. Right, 5 and 7. 7 obviously cannot be either of these, cannot be here, so 7 would have to be here, which means this is not blue, this is or red. So 7 is one of these two. 7 could not be here, so this would then be a 7-8 pair, which would mean this is red and yellow, which means this couldn't be red, this would be orange. But it could not be 6. I mean, that seems okay, right? I mean, it seems fine. 5 would have to be one of these two in that case, which means 5 could not be here. So then 5 would have to be one of these two, which means 5 could not be here. So 5 would be one of these two. Or one of these three. Okay, so then 5 would have to be one of these three. This would have to be a 5-7 pair then. So this would have to be 5 and 7. And this would be red. Which would make this orange. So this would be a 5-7 pair. This would be red, so this would be orange here, which would make that 6. This would be 7, so this would be 5, that would be 7. This could not be 7, so this would not be red, it's orange. This would not be orange, it's red, so that would be 7. So this could not be 5, 6, or 7, it would be 4. That's interesting. It would have to be orange. So we'd have so 4 could not be here, which means 6 would be one of these three. So 6 could not be here, which means where is 6 in the box? It would have to be there. So 6 could not be here. It's one of these three. We would not have 6 here or 4 here. This could not be 5 because 5 would have to be one of the reds. And it would have to be one of these two then. No 6s either. And that seems fine. So one of these is 5, which means this can't be 5 here. Or 5 here. So 5's one of those two. So far, that's looking fine. Obviously, this can't be 7, so 7's there. Remaining digits here are 1 through 5. 5 has to be one of these two because it has to be a red. Ah, and then we have a contradiction. Because 5 has to be one of these two also. Because 5 can't be here, so 5 has to be one of those three. And this is a contradiction. And 5 has to be one of these two, 5 has to be one of these two, 5 has to be one of these two. 5 cannot appear anywhere in column 8 then, if that's the case. So that's the contradiction. So 7 cannot be the one that we're missing then. So 6 has to be in the red. So this is 7, 8 as a pair. 7 cannot be here. 7 cannot appear here. This is 7, 8 as a pair, and it's yellow and orange, which means this cannot be orange. It's red. This is 5, 6 as a pair. Oops. 5, 6 as a pair. So this is yellow and orange. We're not sure which. So this is one of each of the colors. We don't know which, though. So 7 could potentially be here. The only reason why this was 7, though, was because 7 couldn't be here. 5 couldn't be... Right, 7 had to be here. This had to be 7, 8 as a pair. And this couldn't be 5 because one of these was red. Which means 5 had to be one of these. Why couldn't this be 5? Hold up. Maybe I messed that up. So let's try that again. I don't know if that was actually accurate. So then this is 6, this is 8, which makes that 7 and 8 there. So no orange, no yellow. This is red. No 6, so this is yellow here, obviously. Because 5 had to be here. That's the reasoning. 5 had to be here, which eliminates 5 from there. Which means 5 has to be one of these two. Which means 5 cannot be here. 5 has to be one of these three. 7 has to be one of these three, and that's the reason why. Okay. So that's still kosher. So then we know... Oops. This cannot be 7 in the reds. So it's 5 and 6 in the reds. And I don't think... Well, the thing is, we knew that 7 had to be here, right? And that forced a certain situation around here. But with 7 and 8 being yellow and orange, that forces this to be red, which is possible. So this can't be 7 here, so 7's either here or one of these two. This is 7, 8 as a pair. Which means this is red and yellow also. Sorry, yellow and orange. This is red, so this is yellow or orange. Which could be the 1. This cannot be 5 or 6, though. Oh, interesting. So this could be red here. We don't know. Seven's one of these three. One of these is red, at least. Could both of these be red is kind of the question. If both of the... Well, the thing is, does allow a red here, right? One of these two... Oh. Well, there's one inch thing. One of these is guaranteed to be red here. Because... Right, because this can't be red. One of these has to be red to be with 5 and 6. Which means... Well, at most, one other color could be red. Sorry, one other digit could be red. Because we have guaranteed at most one red here, and then this is red. And this has to contain 5 and 6. Interesting. So... Right, this is red. It's guaranteed this is 5 or 6. That's guaranteed. What else do we have? So can this not be not red here is kind of my question, right? So say we had this as red. This is obviously red 2. And would have to be 6. So that would be 6. This would be 7. It could be 4 technically. 7 can't be here. 7 would have to be then here. So 7 would be there. This would not be 7. Obviously, this wouldn't be 7 either. So this would be 7 here. And this would not be red. So this would be the orange. This would not be orange, so it would be red. No 6 here. 6 could not be here. This is 4, 5 as a pair. This could not be 4. Because, sorry, this cannot be 5 because 5 is red. So 5 has to be here. This is 4. That's interesting. There's no 4. So this cannot be 4. It cannot be 7. 6 has to be one of these 3. So this cannot be 6 here. Which would force this to be 6 here. So 6 could not be either of these. Which means this would have to be 6 here and not blue. So this would be 6. 5 and 4 cannot be here. 6 is one of these. No 5 or 6 here. So this would be a 1, 2, 3, 4 triplet. This would have to be red. 6 would eliminate 6 here, so it's 5, which forces that to be 6. So this is still valid. 4 eliminates 4 here. This can't be 6 because of 6 in the row. 4 is one of these. 6 cannot be here, so this must be 6 here. And is red. So far that's looking okay. This can't be red or dark. So this must be yellow. That means this can't be yellow here. It's dark. Okay, this can't be red or dark, so this is yellow. This is red. 5 is one of these two, so this cannot be 5. This would not be red or yellow, so this is dark. Dark is essentially the orange. Okay, so dark is orange, which means this can't be orange, it's yellow. We have 2 other yellows here. That's interesting. That means one of these has to be yellow still, so it'd be that one. Out of 3, 2, and 1. So this couldn't be yellow. One of these would be yellow then. Okay, that seems fine. 5 is one of these two. We don't know which. Obviously, this can't be 5. So far, this is looking okay. 5 would have to be one of these two. 1 could be here as a red. So this would be AB. They would have to be different colors. Now this would be orange, so this couldn't be orange here, which means that's red, which means this can't be red or orange, it's yellow. So this would have to be orange or red. I don't know which. We'd have 2. Okay, so then 2 of the colors would have to be the same as, well, not necessarily. No, 2 of them would have to be the same. So 4 cannot be here. 4 cannot be here. 4 would have to be here. So this would have to be orange. Which means this can't be orange. It's yellow. This can't be yellow. It's orange. Which means this can't. This is 8. 7, 8. Which means this is not yellow. This is not orange. Hmm. 4 would have to be one of these. Okay, so this could not be 4 in that case. So 4 is one of those two. 4 is orange, so 4 could be any of these 3. So I guess you could have 2 and 3 here. In fact, I would think it would have to be 2 and 3, right? Because if this isn't 2 and 3 here, one of them's 1. So then, well, I guess this could technically be yellow also. You could have 1, 2, and 3, right? This would have to be 5. So that eliminates 5 here and 6 here. So C is yellow. A and B, one of them's yellow, one of them's orange, but one of them could change. This is looking kosher. I might have to stop soon because actually I have a hard stop on this time. Probably should have started this a little earlier or just kept this a little because I didn't think it would take this long though, unfortunately. 6 here, that makes this 5, which makes that 6. Okay, this can't be 5, so this must be 5 here, which means that's not blue, that's red. So this is red or orange, so 4 can be either of these. 7 again could still be here. This is 1, 3, 4, or 7. This can't be 5 anymore. Yeah, this is looking like it could be the answers anyways. And I have a hard stop that I need to go to, so I'm gonna stop it here. And we'll continue with this in the next video. I'll see you in that video then. Take care.